Hey, welcome back to Algebra 2 Easy. Today we're going to work on solving exponential equations and using laws of exponents. So let's take a look at problem 1 here. We have 5 to the 3 minus 2x power equals 5 to the negative x power. Now, because you have a base of 5 and exactly one base of 5 on either side of the equation, that means that we can ignore the bases. Imagine dropping those away. So because the base values are equal to each other, that means that the exponents must also be equal to each other. And now we can solve for x. I'm going to add the 2x to both sides, and that gives me positive x, and x is equal to 3. And that's your final answer. You can absolutely take your answer and plug it back into both expressions to make sure that it works and that you get the same number, and you can use your calculator to do that. Let's take a look at number 2. Now, number 2 looks like number 1, except the base values aren't the same. But if they were, if the base values were the same, then I could drop them out of the problem and solve for the exponents. So your job is to make the base values the same. I have an 8 and I have a 2. Always pick the larger of the two numbers and ask yourself, could I change this to 2 raised to some power? 2 to what power would give me 8? Well, that is 2 to the third power. And then we still have the x minus 1, and it's still equal to 2 to the x plus 2 power. So now remember your exponential properties. We are going to take 3 to the power of x minus 1, which means you're going to multiply. That's a power to a power. So that becomes 2 to the 3x minus 3. You're going to distribute that 3 to everything. And that is equal to 2 to the x plus 2 power. The base values are now the same, so I can cancel them out. And I'm left with the exponents being equal to each other. 3x minus 3 equals x plus 2. I'm going to subtract that x, and I get 2x minus 3 is equal to 2. And then I'm going to add that 3. I get 2x is equal to 5. And then I'm going to divide by 2. X is equal to 5 halves. All right, let's take a look at number 3. Very similar to numbers 1 and 2. Actually, more similar to problem 2. We need to make the base values the same. And they almost are. You have a 2 and a 1/2. If I could somehow rewrite that 1/2 so the 2 was on top, then I could cancel the bases. Well, if you remember, when you have a negative exponent, you write the reciprocal of your base value. So for instance, if I have 1/2 to the x, I could rewrite that as 2 to the negative first power raised to the x. So 1/2 is the same as 2 to the negative first. And that's still equal to 2 to the x plus 3 power. Now, again, you have a power to a power, so you're going to multiply the negative 1 and the x. So I get 2 to the negative x power is equal to 2 to the x plus 3 power. Now that the base values are the same, I can drop those away, and I can solve by setting the exponents equal to each other. I'm going to subtract x on both sides. I get negative 2x is equal to 3, and then x is going to be equal to negative 3 halves. And there you go.